Hi, this is Steve with iFLOW and welcome to our video series. In this segment we're going to look at the cost, benefit, and payback of investing in an iFLOW combination system. We're going to look at the various ways that payback can accrue using the iFLOW system, and we're going to compare it to, let's say, the increase in your mortgage payment to see how the offset is. Because we know at the end of the day, an investment or in an upgrade in your HVAC system has to come with a payback. There has to be some benefit. So we want to show you what those are so that you can make a clear decision when it comes time to selecting your HVAC system. We want to look at it from two perspectives. We're going to show you all the benefits that can accrue from it, but we also want to look at the disadvantage if you don't invest in it. So if you can choose to upgrade your kitchen countertops, your hardwood floors, your appliances, your fixtures, and those are all visual, and we know that they add some pleasure to your lifestyle, and that's great. The HVAC system also adds that. You can't see it because most of the time it's in your basement or in your garage or out of the way, but really that's providing comfort 24/7, 365. All right, that's really going to make you comfortable in your home and to all parts of your home, and it's going to determine how comfortable you are in your home. So let's start by looking at a survey done by Emerson. Emerson, you would recall, is a thermostat manufacturer, and this is a survey of a limited number of customers they did, but here's the feedback. 76% of customers aren't comfortable in their own home, and a home is where they spend 69% of their time. So that's significant. 76% of the customers say they weren't comfortable in their own homes, a place where they spend the majority of their time. 61% of the respondents said that some room in their home is too hot or too cold. Right? So too hot, too cold, which leads to 48% of them adjusting their thermostat daily. Well, your thermostat's on the wall in your home. It really should be looking at the temperature and bringing on the air conditioning or the heating as needed to maintain the set point temperature. But if you're having to go physically to the thermostat and turn it up or down, that means that it's not sensing the right temperature. You're uncomfortable, so you actually have to go and physically, manually adjust it, and that's not right. So let's look at it from, so we know that there are issues out there with the present HVAC systems. If there weren't, you wouldn't have that type of response rate. 76% being uncomfortable, 61% of those respondents saying too hot, too cold, and 50%, almost 50% adjusting every day. You wouldn't have those numbers if things were working the best they could at the present time. So let's look at the cost of that.
There is one complaint that we always get from homeowners. It is that it is uncomfortable. The wrong temperature from room to room, from floor to floor.
So that's Richard Trethaway from This Old House. So I want to go through that once more and listen carefully to what he's saying. He said it's uncomfortable. And we get this complaint all the time. It's uncomfortable, different temperatures from room to room and floor to floor. So let's listen once more. Oh, sorry.
There is one complaint that we always get from homeowners. It is that it is uncomfortable. The wrong temperature from room to room, from floor to floor.
So what he's saying is really confirmed by the Emerson survey that we saw previously, that he gets the complaint all the time, uncomfortable from room to room, floor to floor. There's a cost to that, right? When you purchase your home, you want to make sure that you can use every square footage of it. If there's a room or an area of your home that is uncomfortable, too hot or too cold, you still pay for that. You're not going to be able to call your real estate agent and say, listen, this home doesn't have a great HVAC system, so give me a discount on the house. It's most of the real estate are done by, the analysis is done by comps, it's all done by square footage. You're really not going to be able to negotiate very much on the HVAC system. If it's not working. If it is working and provides a much better comfort than the others, then we can upsell it. But let's take a look at the the cost. So what I've done here is I've looked at various costs across North America. So we started at 200,000, we have 400,000, 600,000, 800, and then $1 million. So we're looking at a broad range anywhere across the country. You just figure out which matches your area most and use those numbers. But then we're going to look at a standard single-family home. We're assuming 1,600 square feet. 3 floors, let's assume a basement, a main floor, and an upstairs. So to get our home cost per square foot, we just take the actual cost of the home, whatever it is based on your area, divided by the square footage, and we get our cost per square foot. So then with this cost per square foot, we're going to now allocate that on a, let's say, a room by room basis to see what the actual cost is. So if the uncomfortable room is, let's say, just a bonus room, and it's 10 by 10, that's 100 square feet. 100 square feet times $125 per square foot is $12,500. So to have an uncomfortable room at 10 by 10 is going to basically cost us $12,500 in capital cost. Right? That's what we have to purchase the house for, but that we can't use optimally because it's not comfortable. If that was a bedroom, and we're just assuming a standard 10 by 15 bedroom, that's 150 square feet, times 125 gives us $18,750. So again, going up. Now, what about the basement? What if it's the basement that is uncomfortable? Right? We looked at the bonus room, we looked at maybe a bedroom over the garage that might be uncomfortable. That's going to cost you, right now, almost $19,000. What about this? What about this basement? If that basement is 24 by 22, 528 square feet, so again, all we did here is divided the 1,600 square feet by the 3 levels, assume 533, so this is the tightest or closest square footage. So 24 by 22 basement, that's 528 square feet times the $125 per square foot, gives us a cost of $66,000. So if we can't use that basement because it's not comfortable, we still have to pay the $66,000 for that real estate that we can't use as we like. And that's at the 200,000 range. As we go up, let's look at 600,000. So 600,000 divided by 1,600 square feet, 375. Now that 100 square foot bonus room costs us $25,000. That bedroom costs us $37,500, and that basement now costs us almost $200,000 that we can't use optimally. At $1 million, right? If you're in any of the major cities, San Francisco, LA, New York, Toronto, Vancouver, you're looking at $1 million. Divide that by the 1,600, that's $625 a square foot. Times the basement, now we're looking at $330,000. So that square footage that you've purchased in any of those major big cities, there's a significant investment if you can't use it. Now, if I said, okay, if I upgrade my HVAC system, can I use that basement comfortably? Can I use that, the bedroom over the garage comfortably? If the answer is yes, then this payment that you've made now makes it worthwhile. So upgrading your HVAC system might cost you a few $1,000s, but you're going to get the advantage of all of this capital, like this $1 million. Now it's $330,000 worth of real estate that I paid for that I can use. All to say here is that there is a cost to not being able to use all of the square footage in your home comfortably. And based on square footage, you can calculate what that is and decide whether you want to upgrade or not upgrade. So, all to say, don't ignore the mechanical systems, right? Treat yourself for the next decade or so. Make an investment in your thermal comfort. Choose iFLOW as part of your HVAC system. So again, the incremental investment in an iFLOW combination system that can enable you to comfortably use all of this space comes with a significant advantage. So that said, that was just the real estate cost. right? The real estate cost of the square footage, and can we use it or not use it? Okay, how much is that costing us? Now let's look at the benefits, the cost benefits that we can accrue or that we can earn using the iFLOW. The first we're going to talk about efficiency. So we're talking about the gas efficiency, the electricity efficiency of the system. So here in this red line that we have is a 95% two-stage furnace, and we're comparing it to this orange line, which is the iFLOW with a condensing tankless water heater, in this case the Navien. So this orange line shows a significant improvement. So all of this area in green is a significant improvement over the baseline 95% AFUE two-stage furnace, and it's giving you all of that green in the area where you use the furnace most. So that area in green, that 15% improvement in efficiency, those are dollar savings to you, right? So this is the efficiency side. When we mark that out, in the red we have the 95% furnace with a 0.62 tank. And what that's comparing is, let's say, a baseline builder spec with a 95% AFUE furnace. Yeah, really fairly good, looks good on paper. With a 0.62 energy tank, a regular tank type water heater. That'll be our baseline. And then we're going to compare again to the iFLOW and that Navien combination. So that the iFLOW Navien is in orange, and the 95% two-stage furnace with the tank is in red. So we see here, this is actual energy cost. So obviously the 95% with the tank is going to be much higher than the iFLOW and the Navien in all of the different areas. The efficiency, obviously the orange is going to be much higher than the red. Gas consumption, because we are more efficient, the iFLOW and Navien combination, our gas consumption is going to be lower, so the orange lines are lower. And then greenhouse gases, of course, if we're using less gas because we're more efficient, then we're going to be emitting less, right? If I have a car that gets a much better MPG and I don't have to put as much gas in it to go the same distance, that means I'm emitting much less as well. So it's the same idea. Here our emissions are less than the furnace and the water and the tank type water heater option. So those are some of the tables. Now let's compare that and put that into to table form. We've got 5 different areas, all have different utility prices, so that's why there's some variance in the actual costs and the efficiencies. But at the end of the day, let's look at the averages. So on average, across these 5 locations in the US, we are saving approximately 33% in efficiency. That works out to $266 a year. If we look over 7 years, that's $1,862. If we look at over 10 years, $2,660. So there is some payback based on the efficiency, the combustion efficiency of the system. That efficiency, as again we just mentioned, results in reduced emissions as well. So again, given that we've saved 33% on our utility cost here, we're looking at about 30% savings in emissions, so less emissions. So not only is it greener and better for the environment, it's putting money back in your pocket. So that's one way we can save money, just by better gas efficiency. 2, let's look at the Wi-Fi and smart thermostat setback capability that we have with the programming in the iFLOW. So 3 out of 4 of our units have Wi-Fi capability. With that Wi-Fi capability comes a smart app. With the smart app, you have many of the features that your smart thermostat has, including setback. So because we can use those features, let's look at what the potential savings might be. So the concept is simple. Why heat and cool a space when you're not using it? Right? If you weren't in your home, would you keep the thermostat at 72 degrees? Likely not. Right? And for our friends in Canada, for example, it's 22 Celsius. If, for example, you went south for the winter, you've gone to California or Florida or Texas for the winter, are you going to keep your home in the Northeast at 72 degrees? No, you're likely to reduce that and reduce it significantly. You can keep it, you don't want to freeze your pipes, but you might keep it at 45 or 50. That is what we're really talking about. And then in the summer, if you go away on holidays, are you going to leave your air conditioning unit running in your home? Absolutely not. You're going to turn it off. So we're talking about that those concepts. So the main advantage of a smart thermostat is the potential to save energy. Energy when you're not using it, right? So the ability to match temperatures to time schedules, right? Oh, I'm not going to be, I get up in the morning and I go to work at 7:30, for example. All the kids leave for school around the same time, so nobody's home from 7:30 to 4:30, for example. Everybody gets home at 4:30 and then bed at, let's say, 10:30. So we can set some different times for those. So being able to match your temperature to the time schedule, and that could be programmed or learned, is what we call setback. Or one of the advantages of the smart thermostats, and the ability to employ deep setbacks during those periods to reduce energy. One way the Nest does that, for example, it has an away function, so it can detect when nobody is crossing in front of the thermostat. Right, the thermostat has a motion sensor in it. When it sees somebody there regularly, it will maintain the temperature. If it sees nobody crossing in front of that thermostat, it will assume you're away. And when it's away, then it goes into your eco mode, right? And that eco mode can be set as low as you like. In terms of savings, right? The Nest did their own study, which they submitted to the DOE, and it estimated 11% on heating, 15% on cooling. So if, based on the average energy costs across the country, they estimated somewhere around an average savings of $138 a year. The DOE, in their Energy Star program, estimated about $180 per year in energy cost savings. Right, so Nest 138, Energy Star 180. So let's say 140, 180. We're going to take the average and use 160 as an average when we do our calculation. But I just want to note where that's from. As I mentioned, the iFLOW smartphone app delivers many of this scheduling capability, so we can set daytime setbacks, nighttime setbacks. We have that same capability built in, so those similar savings will come to you. This is just a look at our scheduling. We are actually just in the process of updating it, so the interface might look a little different, but the features will still be there and the capabilities. Right, so you can go in, you can adjust from the thermostat, you get your local area temperatures, your weather conditions, you can have heating, cooling, or just run your fan for circulation. You have that capability. You can adjust the temperatures up or down, depending on whatever modes, right? Heating, then up or down, cooling, up or down. And then you can schedule it. So, for example, as I mentioned, if everybody goes to work or school at 7:30, hey, you can drop the temperature, depending on which season you're in, but you can drop the temperature. You don't need it. Drop the heating temperature, or turn the AC off and let the temperature rise. Why? Because nobody's there during the day. And then if everybody gets home at 4:30, well, perhaps at 4 o'clock you'll turn on your heating or turn on your air conditioning to condition the air, depending on the season you're in, at that time, so that when everybody gets home at 4:30, it's comfortable. And then you keep that temperature from 4:30 to 10:30, for example, and then at 10:30, when everybody typically goes to bed for the evening, well, then you can go back to your nighttime setback, right? So drop the heating, drop the heating, drop the cooling as well, or drop the cooling, yes. Sorry. But again, and you can have 5-day programmable, 5-day +1 +1. If Saturday and Sunday are different, you can have 5 + 2, or you can have each day independently programmed. So we give you lots of capability that way. So those savings, as I mentioned, $160, right? So we have the gas savings, which were $266 a year. Now we have the Wi-Fi and setback capability, delivering about $160 a year. And now let's look at zoning. So with the iFLOW units, we have units that can do 2, 3, and 4 zoning. So what we do with zoning is we divide your house into different sections, and we deliver only the heating and cooling to those areas as needed. With a single zone system, there's only one thermostat. That thermostat's going to be installed typically in your hallway. It's able to look at the temperature around that thermostat, but it's not able to look at what your temperature is upstairs. It's not able to look at what your temperature is downstairs. So really, it's looking at the temperature in the main hallway typically, and using that as a proxy for the rest of your home. But as we saw by the Emerson survey, many cases, right, almost 50% of the time, you have to go to that thermostat and adjust it. That's one of the downsides of that single zone system. In terms of savings, we're looking at the same idea as we did with the setback in the thermostat, right? We said, hey, if I'm going to Florida for the winter, why am I going to keep my house at 72 degrees? I'm going to drop it in the winter to 45 or 50 degrees. That would be more than enough to keep the pipes from freezing, to keep it warm, and to save money. Well, let's look at your home. So now take that same concept, and instead of just my home as one zone and whether I'm away or not, what if I divide my home into zones and say, well, okay, I'm not using the upstairs during the day, so I'll keep the AC off from the top zone. But maybe somebody is home during the day, so the main floor will keep at temperature, but the upstairs we won't. And the basement, in the summer, it's going to be comfortable anyway regardless, so we won't do the basement. So that same idea of being able to, in my home or away, if I'm not, let's turn it down. We're going to use that same idea, but now based on a floor by floor or room by room scenario. Right? If you weren't in a certain zone of your house, right? Zone 1 upstairs, zone 2 middle floor, zone 3 basement. If you weren't in a certain zone of your house, would you keep the thermostat set at 72? And you don't have to. Right? So for example, if you only use the upstairs bedrooms in the late afternoon or evenings, then why cool them all day? Right? There's just wasted energy. We don't have to heat or cool them during the day. So with the iFLOW zoning, you have the capability to deliver temperatures on a floor by floor or zone by zone basis. So there we get some additional savings. So let's look at that. So iFLOW reduces the utility bills as it enables homeowners to maintain the desired temperature in the individual areas rather than unnecessarily heating or cooling the entire home all the time. So the zoning combined with that temperature setback will save us money by delivering the temperature controlled air, or so the conditioned air, whether that's heated or cooled, only to those zones and only when it's necessary. Right? And as depending on where, or depending on the different zones and how we've divvied up your house, that will determine which zone we deliver heating or cooling to. So, according to the U.S. Department of Energy, a zoning system can save up to 30% per year compared with a typical heating and cooling system. So 30% of a typical heating and cooling bill is about $1,000 a year for energy. So 30% of that would be approximately $300 a year. Right? So this is the $300 a year through zoning, right? Through zoning. In a Canadian study, and this is a smaller study, and this was done by Natural Resources Canada, and is available on this website if you want to go take a look at it. The upper floor called for 80% of the cooling demand during the afternoon peak period. And obviously in the afternoon peak period, that's usually when nobody's home. So those, in my opinion, is there are avoidable costs. One interesting note, the basement zone, so in this small study that they did, the basement zone never called for cooling at all during the summer, right? So you don't need to cool the basement. It's already cold enough. The thermostat never calls. Alternatively, because you don't have to cool it, and it's just a natural cooled space in the summer, because it's underground and getting your thermal comfort or the thermal temperature from the ground around it, you can use that as a source for savings. But that's aside. But let's just look at the actual results from that small study. So they measured the electricity usage in these residential systems. So these are air conditioning or cooling systems. And they measured them during the afternoon peak periods on 12 hot summer days. So they had a single zone system, and then they had a zoned system with afternoon setback. So we looked at this. Obviously the baseline is 100%, and then let's look at how much we can reduce that using the zoned and setback, and the result is significant. So we have saved almost 55%. It's a 55% reduction in the electricity used just by zoning and using afternoon setback. And afternoon setback being, hey, nobody's home in the upper floors, let's say in this case zone 1, nobody's there, turn it off. The AC doesn't have to run in the upper floor. Even somebody might be on the main floor, so we keep that zone conditioned, but upper floor we don't need it. So why would those costs be so different? Well, in a single zone system, when your AC unit comes on and the blower from your furnace starts to circulate the air and you draw in the return air is drawing from all 3 floors, and it's drawing in and it's mixing and then delivering the conditioned air out to your home. But if if somebody's on the main floor, for example, but we're drawing in the return air from that very, very hot upper floor, that's being drawn in, it's increasing the return air temperature more than it would be if we were just drawing the main system or the main floor, for example. It's increasing the overall average air temperature, so obviously the air conditioner has to work harder to condition that air to the proper temperature that you're looking for and then deliver it back out. So by drawing all of the zones through and having to condition all of that air, even though nobody may be in the upper floor, that's where we're getting those additional costs, right? That's it, up to 80% of those costs were due to that non-zoning of the upper floors, right? That upper floor air being drawn in, and you have to cool it. But with the zone system, what if we just shut the zones for that? We don't allow any airflow into that upper zone because nobody's there. We don't need it. So using setback, we keep that zone closed, or keep it at a lower, in the summer a higher temperature, right? We don't have to bring it to, to 74. We can keep it at 82, for example, or 82, 84, and then when people get home from work or school, then we can condition it to the proper level that we want. So that's the advantage of zoning. With the zone system, only the return air from that zone is conditioned, thus minimizing the operation of the AC unit and offering savings. So again, the DOE, right, estimated $300 per year, right? 30% or roughly $300 per year. Let's assume, and that's up to 300 or up to 30%, so up to 300. Let's assume you're only getting half of those. So we're not trying to maximize the benefit to sell you something that's not going to, or to overinflate our savings numbers. No, let's use half of that, right? Just as a number. So we'll use $150. So now let's look at the cost savings combined. So we had the three sources. We had the better, right, the better engine for improved efficiency. So with the improved efficiency, we were seeing $266 a year. With the Wi-Fi and smartphone, the smart thermostat applications, we saw $160. And then with the zoning, we saw $300, which we're going to use half of, so $150. So let's use those numbers and we'll plug them in. So $266 a year divided by 12 months, $22 a month. For the Wi-Fi and smart thermostat functionality was $160 divided by 12, which is $13.25 a month. Then the $300 savings that the DOE estimated up to, we're going to take half of that, so $150 divided by 12, that gives us $12.50. So those are the three ways that we can save. If we add those together, we get an average combined savings of $47.75 a month. So $575 a year in estimated savings by upgrading to the iFLOW combination system. And that was over a 0.95% two-stage or 95% AFUE two-stage furnace with a 0.62 energy factor water heater. So upgrading to an iFLOW with an Avian tankless, for example, you could estimate $575 a year. So that's fairly significant payback at almost $50 a month. So now let's look at the impact on your cash flow. So we looked at the savings, almost $50 a month. Right? Now let's look at what the costs will be. So we're going to assume new construction. So in new construction, you can add the upgrade, if you wanted to upgrade your countertop, your fixtures, your appliances, your carpeting, your hardwood, whatever the case may be. That's just added to your mortgage, right? So the homeowner bill or the builder builds the house to your specifications with all the upgrades that you wanted, and then that is your final price, and that's the price that you mortgage. If you upgrade your HVAC system, it would be the same thing. We can add that to your mortgage. So we want to look at what the incremental cost to the mortgage would be by upgrading your HVAC system, and then compare it to that $47.75 or almost $50 a month that we're going to get back in savings. And then we'll be able to see the effect on your cash flow. So really what we're doing here is show me the money, right? Let's now get down into it and really see what the benefits could be. So when we look at the cost of upgrading your system, there are three costs. So there's the initial capital investment, right, and that's the cost of the HVAC equipment. Cost of the installation, which in most cases and oftentimes is incorporated into the capital investment of the installation, and then the monthly operating costs. We're going to look at those three. The top two are, or these three are usually offset in that if you go with the standard system, it's not going to cost you as much perhaps, but the downside is your monthly bills will be higher. If you upgrade to the premium HVAC system, your capital cost will be higher, but your savings will be also higher. So the increased cost will be offset by greater savings, right, or lower utility bills. Right, so the standard system, higher bills. Premium system, more capital but lower bills. Right, so it's that offset that we need to look at. Now, in terms of the capital cost, we're just looking at the incremental capital cost. Right, the builder has already built into his package pricing that your house will have a water heater and it will have a furnace, and perhaps depending on where you are, an AC system. So that'll be your baseline system that's already built in. If you want to upgrade, there's going to be an upgrade premium for that. So we're just going to look at the premium, right? The upgrade premium, because one way or the other, you're going to need a water heater, you're going to need a furnace. That's your standard. So we're going to look at the standard system, right? It was a 95% AFUE, 60,000 BTU, two-stage furnace with no Wi-Fi, no zoning. You had a 0.62 energy factor, tank type water heater. So you're roughly looking at about $18.50 as your cost. To upgrade to a premium iFLOW combi system, let's look at a 95,000 BTU iFLOW, and that's because we can do 4 zones with that system. So we're going to have Wi-Fi and zoning. So right away we can see we've got a bigger furnace. We're using 60, now we're going to 95. We have no Wi-Fi here, but we do have Wi-Fi with the iFLOW. No zoning on the standard, but 4 zone capability with the premium. In terms of the water heater, we're going from a 0.92 energy factor tank type water heater to a 0.98 energy factor, so 98% efficient, 199,000 BTU Navian A model. So we're looking at the cost there. We're going to add 4 dampers. We're going to assume 4 zones. So we're going to add 4 dampers to that. We're going to add a circulation pump. We're going to add our plumb kit together, our plumbing kit, to combine the Navian with the iFLOW. And again, it doesn't have to be Navian. We're just using Navian as an example here because that's where some of the comparison data was done on. It can be any tankless water heater, right? All the condensing tankless units, or even non-condensing, depending on where you are in the country, will provide excellent efficiency and better than in most cases the equivalent furnace. So we get the cost to add those costs up. We're looking at an incremental difference in equipment cost of about $3,800. So again, remember the initial costs when we were looking at the real estate costs, right? That basement, for example, on the $1 million home, that was what, $330,000. So yeah, there's going to be a little bit of increase. That's 1%. That's 1% that's 1/3 of 1% of the $1 million house, but that will allow you to use $330,000 of your real estate more comfortably, for example. So we're not looking at significant costs when we look at the total value of the house. Now let's look at the installation cost differential. Well, the graphic on the left has the furnace and the water heater. So you have your furnace with your gas line and with your intake and exhaust as one gas appliance, and then you have your tank type water heater. We're assuming the gas water heater here, tank type, and there are 2 options to the venting on that. You can either go natural draft, right, which means you're going straight up through the roof, or you can be offset. Now if this was a power vented unit, right, so not a natural draft but an actual power vented water heater, then you can actually go to sidewall. So I've just put 2 venting systems on here. We know of course there's only going to be one, but depending on the tank type water heater that you choose, there'll be some differences as to how you're able to vent those. But all to say, 2 gas lines, 2 vents, whether it's sidewall or up. With the iFLOW system, we're going to be tying into the water heater. So it could be a condensing tankless unit, could be a condensing boiler, could be a tank type water heater, could be a heat pump water heater. There are many different options that we're able to use with the iFLOW. The advantage is there's only 1 gas line, only 1 set of vents. So 1 versus 2, 1 gas line versus 2, but we also have to just tee over to the air handler from the water source, water heat source, or hot water source, for example, and we need a pump. So we supply the pump as an accessory, but basically this is what you'd have for your water heater. We're just adding this little tee off into our air handler with the pump and check valve and back in. So, in terms of the installation cost, we think it's going to be here you're installing 2 appliances, 2 vents. Here you're applying one appliance, mounting the other on the wall, tying between them. We think it's either going to be a wash, or the installation cost of ours will be a little bit cheaper because less materials and quicker installation. On that same note, so when we're looking at the installing of the ducting, If we look at a traditional system where you have your furnace and then you have your supply duct running through the different floors and then your return duct running back down, that's your traditional system, no zoning. This is what we would do with zoning. So we go into your basement from the trunk line. We would then supply one zone to the basement, for example, one zone to the main floor, one zone to the upper floor. And in this case, we're going to use the same common return. So all we're really doing is we're eliminating that common supply and replacing it with some smaller, let's say 4-inch, 5-inch, 6-inch, depending on the size you need, depending on the CFM and the square footage, and then adding some three dampers. So in this case, the installation cost would be very similar in our opinion. If we do a damper on the supply and the return, then we're basically eliminating both the supply and the return trunk lines, and we're replacing that with smaller. So we're taking out, an 8x20, 8x16, and then replacing it with smaller diameter, usually round duct, and running those directly from the room down to the unit. So again, even when we're doing the two zone where the supply and the return duct are both modified, we think the cost will be equal, or if not cheaper. And the reason is, when we're running with smaller round duct, for example, we're using less metal, right? So for the same square footage, we're using less metal. So it's about 13% less metal. That less surface area for the same CFM that we're putting through there, right? We're not changing the CFM of the whole house. We're just dividing it and delivering it a little bit differently. That results in significantly less pressure drops. There's going to be, your utility bills will go down because the fan isn't having to work as hard. It's going to be lighter, right? So you'll have less duct reinforcements and less labor to put those in. The longer sections, if we use a 10 or 12 foot length, that's going to be much there's going to be much less, much fewer joints, less labor to do the joints, less duct leakage, so more efficient delivery, and thus lower cost, right? The regular sections would come in 4 or 6 foot lengths, and you'd have to have a joint every 4 or 6 feet. Well, if we're running with round lengths that come in 10 or 12 foot lengths, then there's less joinery to do, so it could be an even quicker install. The 4, 6, 8, or 10 inch all fit into a 10 inch joist, so no problem there. There's nothing else, nothing more to do with that. So, and a lot of those, like if we run with 2 or 3 or 4 of these small 4-inch pipes going to each of the different floors, that'll all fit in the same joist space that you would typically use. So we don't think there's a lot more work to doing a zone system with regards to the ducting. So now we go on to the mortgage cost differential. So we looked at the incremental cost of the equipment was about $3,800. We looked at the installation side and we said, well, it's almost a wash both on the ducting and on the equipment installation side. So now let's look at the how much that's going to add to your mortgage. So if that incremental cost was $2,000 and we had a 10-year mortgage, it would be $20 a month. If it was $3,000 incremental, and then incremental is the upgrade charge for the premium HVAC over your baseline system. If it was $3,000, then you're looking at $30 a month, and if it's $4,750 over 10 years, then you're looking at $4,775. Now, why did we choose that number? Because that number basically, so the $4,775 is what we calculated as our total savings. So I just went to the maximum and said, okay, what would if we were to offset the savings or offset the mortgage exactly to break even with the savings, what would that incremental cost be? So we could actually go up to $4,750 incremental and break even based on the energy savings. If we do it over a 15-year, now why 15 years? Well, 15 years is probably the expected life of that equipment. You know, when we look at the tank, you know, the water heater and the iFLOW together as a system, the iFLOW you might get a little bit longer because there's no products of combustion, but the heat source, yeah, maybe any tankless unit in the market, if it's well maintained, it can go more than 15, but I would say 15 would be a reasonable life expectancy for the equipment. If we do that and use that same 4750 incremental, $33 a month that it will add to our mortgage bill if we amortize that upgrade over the 15 years. And we can go to 20 as well, and we go to 30 depending on the mortgage. But the reason I want to kind of stay with that 10 or 15 is because that matches the life expectancy of the equipment. So now let's put it all together and look at the impact on monthly cash flow. So we saw that these are the increases to your mortgage for the incremental upgrade charge. Here are the monthly savings that we calculated. So let's look at our cash flow. And our cash flow is going to be the estimated monthly mortgage payment increase minus the estimated monthly savings. So for example, in this 10-year scenario, if the incremental was $2,000, amortizing that over 10 years is going to mean our mortgage bill will go up by $20 a month. That $20 a month is then going to be offset by the $47.75 in energy savings that we expect to see, leaving us with $28 positive cash flow in our pocket. Right? That's for the $2,000. $3,000 incremental, we're looking at $18 cash flow positive in our pocket month after month. So we're looking at taking the cost over 10 years, adding that to our mortgage, and then offsetting it by the expected savings, giving us $18 a month. And then we go to the $47.50 incremental. That leads us with, that increases our mortgage by $47.75 over a 10-year period. We're breaking even, right? So the blue is the break-even number. So even if our upgrade costs us $47 or let's say $5,000, just to roughly round it off, increase of $5,000 for the upgrade results in a break-even. Right? So over 10 years, costs us nothing to upgrade, other than you'll be able to use all the square footage in your house. It'll be super comfortable because you've got the zoning, the Wi-Fi, everything is there, all the setback, wonderful system. Cost you zero. Let's look at 15 years. So if we assume the equipment life is going to be 15 years, which it should, we have the and let's just go to the maximum. So we're going to go that almost $5,000 incremental. That's on over 15 years. That's going to add $33 a month to our mortgage. But down here, we're looking at, but again, that $33 is going to be offset by the $47.75 that we expect to save, giving us $15 cash flow positive a month. So on a 15-year mortgage, adding $5,000 upgrade charge for the premium HVAC is going to result in $15 in your pocket every month. And that is in addition to all of the comfort, the benefits that you get by being able to use all of the square footage in your house, and being comfortable with the zoning and with the full modulation and the Wi-Fi capability, all of the rest of it. That's what you get, costs you nothing. Even break at the $5,000, at the break even at 10 year, and it's $15 cash flow positive if we amortize it over 15. So let's look at the National Association of Home Builders in the US. They did a survey of their customers, potential or existing buyers and potential buyers, and it said, and here I quote, "Today's home buyers are looking to incorporate home technologies that increase the long-term value of their house while also providing convenience, safety, and comfort. In fact, the NAHB research shows that most home buyers want an energy efficient home, and are willing to pay for it. Let's further that. Again, quotations end here, so this is all in quotes. NAHB's consumer preferences survey of more than 3,600 recent and prospective home buyers examined the features, products, amenities, and layouts preferred in a new home. In the home technology category, home buyers highly ranked features that improve a home's efficiency, including multi-zone heating, ventilation, air conditioning, so multi-zone HVAC, lighting controls, and programmable thermostats. With iFLOW, you've got multi-zone HVAC, you've got programmable thermostats, you've got energy efficiency. We deliver all three in the one package, and that's exactly what the home builders are looking for in terms of this, based on this survey. So there you have it. Homeowners highly ranked energy efficiency, including zoning and comfort and programmable thermostats, and they're willing to pay for it. But we just showed you in the previous slide that based on the energy efficiency of our system, over 15 years, it's cash flow positive. So this is what the homeowners want. We're giving it to you, showing that the budget works. We think it's a no-brainer. So an iFLOW system, combination system, you get the best. You get the best efficiency of any HVAC system in North America. You get the ultimate comfort delivered. You can use all of the square footage in your house, so there's that initial capital cost is not buried, or you get to use it. And even better, it doesn't require them to pay any more because you can be cash flow positive on your system because the efficiency is so high. So the heating and cooling system of your home determines your comfort day in and day out and the operational cost of your home for decades to come. So one way or the other, there are going to be costs, right? The opportunity cost of not investing in an upgraded HVAC system from the beginning is that, unfortunately, you'll have less comfort and you'll have higher bills, right? As we saw in the beginning, if you go with the basic system, it's going to be cheaper, perhaps, but your monthly bills will be higher. Or you invest in a premium iFLOW system that it might initially cost you a little bit more, but will deliver comfort from the start and then pay you back month after month after month after month so that it is cash flow positive. So your home is by far the biggest investment that you'll make. Why settle for anything less but the most comfortable home you can get? You deserve better. We can do better. Choose iFLOW. I want to thank you for your time. If you have any questions, you can always reach me at on my mobile, my cell phone, toll free, 1-800-985-9227. I am at extension 102, or by email. So either of those, please reach out. We'd love to hear your feedback. If you have any questions, concerns, if you want any of the sources that we've used for this, any of the calculations, I'd be happy to provide them. But thank you for spending some time. I hope this was a helpful kind of review of the cost, the benefits, and the paybacks of a premium iFLOW system. Again, thank you again for your time, and we'll see you next video.